Okay, so this is going to be a pretty shallow but fairly broad overview of Nix. We're going to talk about Nix, the package manager, Nix, the expression language, Nix, the operating system, and Nix, the deployment tool. So we're going to, hopefully, if we can all get through this in 2 hours, we're not going to have time to dive too deeply into any one topic, but we should all have built a cluster that looks like this by the end and deployed it to EC2. So on your handouts, you have a link to these slides. You're going to want to open these slides because there's going to be some copy and pasting unless you really want to type fast. That's cool. And then on the fourth slide, I'll jump back in a sec. I would also recommend opening the fourth slide in just another tab because these links we're probably going to refer back to several times. Okay. So this is what we're out to build, and we want to do it using Nix, and we're going to kind of learn it as we go, hopefully. But by the end of this, we should have this cluster, with one exception. We're not really going to have time to deploy any databases, and that's mainly because spinning up an RDS instance on Amazon takes 20 to 40 minutes just to provision it, so we don't want to wait that long. So we'll do everything but that, but I'll show you how to do it. And then, even though we're not installing Nix on our systems, I'll show you how to do that if you want to go do that later. And then follow all these same instructions. And this is everything that we're going to write. So it's a bunch of files. You don't really need to memorize this slide, but if at any point you start to get lost in all of the many files that we have, you can hop back to this slide. It's number 3, and kind of see what everything is. So the first 2 are just a introductory Nix example. We're not going to use them in our cluster. And then everything else we're going to use in our cluster. So we've got our back-end configuration and the services that run on it. We've got our front-end configuration. We have a proxy, and then we have a target that describes the entire deployment environment. And then if you click on source, there are versions of all these files. These I wouldn't use these. These are mostly for reference because we're going to be building them up as we go. And these are like the final versions. Okay, so there's a lot of links here. Nix is a lot of things. Primarily, it's a package manager, but it's broken up into at least the manuals that we're going to use from the Nix documentation. They're all on nixos.org, and we're going to be using, in particular, the Nix manual, and that's going to help us learn the expression language that is Nix. The Nix packages manual, which will show us things like how to build packages and how to make derivations for our own code. The NixOS manual, which will teach us how to use the Nix package manager to describe an entire server environment. NixOps, which we will use to deploy NixOS images to, or configurations to Amazon. And then there are a couple really nice sort of third-party documentations that Susan Potter put together. Those are at funops.co. And by the way, I apologize for the infun structure. It was a little bit tricky to type, but Susan already took FunOps. Is that font size okay? You want to increase that, or is that okay?
Do a little bit bigger?
Yeah. Okay, so first, we're actually going to skip this step, but I want you to see what it looks like. If we wanted to install Nix, it's just a one-liner curl pipe to sh. And that will install Nix on your system. And when you do that, it's kind of nice. It's all self-contained in a /nix folder, which you need sudo access to create. But then everything will live under that folder. And so if at any point you want to get rid of Nix, you just delete that one folder, and then you're done. So if you wanted to install Nix, you do this, and then you could check it with nix env-version. And since we're going to be using NixOps in this workshop, if you needed to install NixOps, you would do it this way, but we're just going to skip this because we don't need it. So before we get into the fun stuff, let's talk about Nix, the expression language. All Nix configuration is written in Nix, which is an expression language. So while it's primarily a package manager, it's also a language. And I think this is probably the most important thing to take out of this workshop is learning the expression language. It's probably, at least to me, it's the least exciting because I want to build stuff and deploy it. but which is how I started with Nix, and then I realized at some point that I was just cargo culting, off of everyone else's configuration, and I didn't actually know what I was doing or how to modify it, and that became a pretty big roadblock. So I forced myself to step back and learn the expression language, and it's actually not that difficult of a language, and that really unleashed my ability to customize my deployments. So if you go to this link, it'll walk you through all the stuff in much more detail that we're about to look at sort of briefly. But for the first step, everyone SSH into your respective environment and fire up the Nix REPL. And so I'll do this along with you. Okay, so first we're going to open up the Nix REPL. Bear with my typing, this is kind of a funny angle. So first we have simple values. These are oh, actually, before I go into there, Nix is pure lazy functional language, but it's also dynamically typed. So if you're used to Haskell or whatever, this might throw you. It definitely threw me, but we'll see some examples of that. So we have simple values like numbers, and we can do basic arithmetic, for example. We can represent strings in double quotes. We can concatenate strings with the double plus. Oh, by that I mean the single plus. Yeah. We can do multi-line strings with a double apostrophe. Is that high enough, the bottom of that? Yeah? Okay. And you'll notice that Nix is pretty friendly about spacing and indentation and line breaks. I don't know if or what the sort of best practices is for formatting code. For this, I tried to format it in a way that kind of works for slides. So you can take that or leave it. Okay. We also have lists, which are expressed using square brackets and just spaces. So something like this produces a list of integers, 1, 2, 3, 4. Lists are also heterogeneous, so we can stick all kinds of different values in one. So we could have a number and a string. We could even have a path or another list. And you can see when this is shown, it doesn't actually render the inner list. That's because Nix is a lazy evaluated language. And finally, sets. Sets are probably the thing you'll run into the most when you're in your Nix configuration. And a set is kind of I'm not sure why they chose to call it this, but I call it an object or a map. But it's basically a collection of key value pairs written using curly braces and semicolons. So we can make a set with a variable x, and we can say x is equal to 1. And again, as I said, spacing is pretty unimportant. We can have another variable y, which is equal to 2. And there's our set. And with a set, we can refer to things inside of it with just dot notation. So if I take this same set and say dot y, I can get the y out of it. Also, if I set it equal to a binding like foo equals this set, then I could say foo dot y to get the 2.
When you have a /var/log, the path, is that considered a string by Nix?
Yeah, so the /var/log here, that's not a string. That's a special path type for want of a type. So Nix understands that that's a directory or a file path.
I assume the order is not important in a set?
Right. In a set, order is not important. It's just a unordered collection of key value pairs. The only thing is important is that the keys are distinct.
Do the keys have a type?
Do the keys have a type? I have no idea. The keys themselves, that's a really good question. So like, could you set a key programmatically? Is that what you're asking? I don't know. Try it.
Is there a way to ask this type of question?
Yes.
But you can't really ask for the key itself.
Well, oh, that's a good point. Let's try. Asking for the type. Well, that's going to give us the type of the value. Yeah, so maybe they're strings. That I don't know. All right. We also have functions. Those are pretty important in Nix configuration. The syntax of a function is a variable followed by a colon followed by the body of the function. So if I want to make a square function, I would say square equals, and I'd give it an argument called x, and then a body of the function, so x times x. So square is a function, give me an x, I'll give you an x times x. So if I say square of 7, I get 49. If I want to do multiple argument functions, I can curry them. So I could say something like times is a function that takes an x and returns a function that takes a y and returns an x times y. Now I can say times of 6 and 7 to get 42. If instead of a curried function, I want a one argument function that takes many values, I would pass in a set. So instead of the curried function, I can say times equals a function that takes a set with an x and a y, colon, and then returns x times y. And now I can say times, and then the argument is x equals 6, y equals 7.
What is the difference between you don't specify, well, say change y to z?
Okay, so if I try calling times and I don't give it a y, it will blow up.
If it has extras.
Yeah, that's a good question. So if you scroll down, if we pass the correct values x and y, but we also pass a z, it blows up. It doesn't want that, and that's because of the way we declared it. So we declared it like this. We said times is a function that takes a set of only 2 fields. Many times in Nix, you're passing around configurations that, or sets of configurations that came from other places, and you don't always know what all the fields are in there or care. So if you want to allow extra variables, you can, or extra fields, you can just say comma dot dot dot, and now you can call that with any extra values that you like, and the z and the ASDF will just be ignored. And then finally, we can have default values. That's also used pretty often in your config. So let's say that we don't want to pass in x for some reason, or let's not pass in y. So this fails because it's missing. So if instead I declare it with a default, so we'll say x and y, and then the syntax is a question mark followed by the default value. This says times is a function that takes an x and a y, and by the way, if no y is supplied, it's 7. And so now I can say times of 6 and 7. Oh, right. As before, it should work, and if I omit the 7 or the y, it should work as well. Okay, are there any questions on sets or functions? Because those are probably the 2 most important. Yeah?
With that dot dot dot, is it possible to write the function so that, like, let's say you're taking a function and you know certain fields you want to multiply together, and then you want to return another set that also has anything else that was coming along with it?
But
So-
then access the rest of it.
So you want to return a set that includes some of the stuff that was in the input set
Yeah.
without knowing what they are.
Yeah, I don't know what they are.
I don't know. There's a way, if you know what they are, that you can pass them along without having to type x equals x, y equals y. I don't know if there's a way to look them up. But this would be a question that we could go to, if we go back to slide 4. This would be most likely in the Nix manual. And sorry, let me go back to my own link here. So if we go to the expression language section, I would probably look around for it here. I don't want to spend too much time on that now, but that's where I would go. By the way, I would say that learning to use these manuals is probably the second most important thing to take out of this workshop. They're pretty good. There's a lot of stuff that's not in there, and I often find myself going into the source code of Nix packages, either because I'm looking up an example or I just don't know where something is. But otherwise, these manuals are pretty well done for what they are. Okay, so that's functions. We also have let expressions, which shouldn't come as too much of a surprise for most of us, I think. The syntax is let, and then we can have a series of variable bindings, each separated by a semicolon. So x equals 6, y equals 7, z equals 8, even though we won't use it. And then we say in, and then we have another expression that can use those bindings if it wants. So we can say in x times y, and it returns 42.
Can you let a set?
Say again?
Can you let a set?
What do you mean?
Let some set be instructed something from set?
I don't quite understand.
Probably not important.
Uh,
Say like let the set x, y equal something.
I don't know. Let's try it. So something like this.
So only for the function, yeah.
X, y equals, I don't know if it has pattern matching like this, but let's try it. I'm totally guessing how this might work. No. Okay, we can also do recursion by using a let expression. If we were to try to just write this part and evaluate that, this line would fail because fact prime is not defined yet. We're in the process of defining it. So first we have to define fact prime in a let expression before we can reference it or let it reference itself. So if we wanted to make a recursive factorial function, we would just do this. And so I don't feel like typing all this, so I'll just paste it. So now I can say fact 5. And if I say fact prime, it won't be found because it's hidden inside of that function. There's a lot of built-in operators, and I encourage you to check out this section of the Nix manual. I think I have found this set combination operator to be pretty useful. I also put list concatenation. I think these two you're probably likely to run into, but there are lots of others, and you should check those out. So yeah, we can concatenate lists. That's where the double plus comes from. That confused me before.
Doesn't that answer that earlier question about to update the record? Isn't that?
What's the question?
Well, I think somebody earlier on asked about how you would produce a new set based on an existing set to replace one of these.
That would work so the question is about, can you use this operator to return all or part of an incoming set as an argument to a function? Maybe, although the incoming set is not provided as a single value. It's provided as, well, I guess it depends on how you write the function. So if I were to write a function foo equals x, and then I returned x, and then I combined that with another set, z equals 8, and then I called foo with x equals 6, then I can combine them. But if I instead wrote foo like this, I don't think that would quite work, unless x happened to be a set within the set of arguments.
I was going to ask something related to that, but just in there, could you in some way, maybe it doesn't make sense that the has to describe some set structure. You can't nest those declarations.
Not that I know of. I mean, it can have any structure in practice because it's dynamically typed,
Sure.
but I don't know if there's a way to declare it like that.
This structure will be checked, right?
Yeah. So you're saying something like,
Yeah, something like that.
I don't think so, but let's try it and see what happens. Oh, I'm missing a brace. Oh. Yeah, I think the parser is choking on this part. And then there's also a standard library with functions that you're used to, like map and fold. Those you're probably not going to run into that often, but I used both of these to create the server that you're all on, because I had to create 1,000 accounts for everyone. So I just folded over a list of 1 to 1,000, and I mapped that into a user object, and then I returned that as a list of the users for that NixOS box. So these were useful that one time, so I threw them in because they're kind of neat. But yeah, you might not run into them that much.
Do you know if there's a way to import the built-ins?
Mm-hmm. Yeah, so in the REPL, I think you can do import. Oh shoot, I think so. Let's see if we can find it. Well, NixREPL is a separate project, so I'm just going to pull up its documentation. Oh, I didn't know that. Cool. Okay, so then it should be here somewhere.
I can do this asynchronous. I don't need a derail.
No worries.
Colon A. Get added to the scope.
Cool.
Thank you.
Thanks. So for the video, :A will import into the NixREPL. Okay, so let's take just a few minutes to try Fibonacci. Sorry, Michael Snoyman, I don't know if you're in here, but I did it. And then take that and see if you can use that in another function that computes a list of Fibonacci numbers. The answer is in the next slide, so don't peek. One thing you might want is if then else. There we go. So there's a conditional section. The syntax is if expression, then expression, else expression. So something like this.
It's on the fact slide.
It's on which slide? Oh, yes. If you guys want to drop stuff in the LambdaConf channel, it's probably the best way to share information. There is a Nix channel, although it's not LambdaConf specific, so I don't know, it might be rude to just put conference-based stuff in there.
People have been, because you can reply now to create a thread on a thing.
Oh, that's a good idea.
People have been replying to one thread.
If you go up to the my slides message, maybe create a thread under there. And
Yeah, they click the reply here. Oh, no, it's a share. Never mind. Second one. So all the replies are to that comment.
All right, does anyone have an answer that they want to share? I don't know. Cool. Oh, I like that. That's neat. That's better than mine.
What's the channel?
If you go to the LambdaConf channel, there's a thread under this message where I put the slides link. Uh-oh. Oh, I think you're missing a case. Oh, I'm missing a 0. Got it. Cool. So that's pretty similar to yeah. I think your colon, Daniel, goes at the end of your ends. Cool. All right. So I think we can probably move on. So here's a similar. I used range, which is a function that takes 2 arguments and gives you a list of integers. So if we did. Use this handy syntax from before. I'm not sure if this will work, but let's try it. Oop.
What was that definition said? That's non-total, right? You have 0 to it, correct?
Question?
Yeah.
So, what was the thing that gives the import? Is it special form or?
Yeah, I kind of glossed over that because it's not super important for this part. We'll see this a bunch in the configuration where the REPL is a little bit different from the configuration. Okay, so I think let's press forward unless, well, let me walk through this example. So fib is going to be the result of evaluating this let expression. And within the let expression, fib prime is a function that takes an n, and if n is 1 or 2, returns 1. So this is indexed by 1 instead of 0. Otherwise, return calling fib prime of n minus 1 plus fib prime of n minus 2. So that's in our, that fib prime is in our let bindings, and then we return it. And then for fibs, I guess I did have the same thing that you guys had. It's just a function that takes a list and maps fib over it. And then we can produce a list with lib.range, which is in the regular Nix packages. And we'll see this syntax a lot shortly. Okay, so that's a really quick overview of the expression language. I think, based on my experience, that's most of what you'll need to be able to read and write Nix configuration. There's a lot more, so you'll want that manual handy. But sets, functions, let expressions, that's the most useful stuff. So Nix is more, I think most people would consider Nix to be a package manager more than a language. So let's look at the package manager and how to use it. So in your SSH, drop out of the Nix REPL back to the prompt. And we're going to be using this nixenv command. So without going on too much of a tangent, the way Nix works is there's a repository of packages called Nix packages. And when you want to install packages from that repository, they get downloaded and put into your Nix store, which in this case is in a directory called /nix/store. And there's a bunch of directories with SHAs in them. And where that's coming from is Nix tries to make builds reproducible, or at least make artifacts reproducible or identifiable based on how they were built, what versions of what libraries were used to build them, and things like that. And so when they get published to the Nix packages and you install them locally, it retains all of that hash information, so you can be sure you have the right version of the right thing. This is really useful. I think the first usage I had for Nix was not for an operating system or for operations. It was simply to be able to have multiple versions of the same thing on my computer and not have them step on each other. So for example, if I needed Node.js version 0.6 and version 0.7 installed on my computer, I didn't want to have to deal with them reading and writing to the same directories, right? This is very similar to a Cabal sandbox, except it's kind of at the system level. So with Nix, I said install Node version 0.7 and install Node 0.6, and they're both in my store. And then you have to tell Nix which one you're interested in using at any given time, and then it does some symlinking magic and some environment variable magic to actually make that available to you. So that's what we're about to play around with. So if you try to run fdupes, you'll see that it's not installed. But that's a package that's available in Nix, and so we can search for it with nixenv-qa. You'll often use a capital P. We don't need it here, but I'll just throw it in. And so I want to search the Nix package repo, and that will basically give me a list of all the packages, which maybe isn't that useful. So I can grep for specific packages or patterns that I might be interested in. So show me anything with fdupes in its name, and we should get one. Okay, so the fully qualified attribute name is called nixos.fdupes, and we can install that if we go to the next slide. Before we install that, we'll use it sort of temporarily. So Nix has the ability to run a shell with a specific environment local to that shell instance, and it goes away when you quit the shell. So we'll try that with Nix shell, and we're going to pass the -p flag and tell it we want the package, so P is for package, fdupes to be available in our Nix shell. And if I hadn't already done this, you would have seen it downloading from the Nix packages repo and unpacking things in the place they need to go. But so now I'm running a Nix shell, and if I want fdupes, there it is right on my path, so I can run it. And then as soon as I quit out of my shell, it's gone. So the binary is still on the machine. It's just not in my path. It's not in my current environment because I haven't expressly told Nix that I want it. Was there a question? Yeah.
So where do the packages come from?
The packages come from whatever's in your Nix channel. I need to be root to do this. So I'm going to SSH into, oops. So right now they're coming from the NixOS 17.03 channel. If you install Nix without NixOS, it'll be a slightly different channel, but basically it's this curated thing that's hosted by NixOS and a bunch of mirrors. And you can find information about that in the Nix manual under Nix channel, and there's plenty of detail there. By the way, on NixOS, to like upgrade your system to the next release, all you do is change this channel and then rebuild your system.
I have a
Yeah.
couple of questions. One is, are these channels immutable? In other words, the packages in that channel, will they change over time?
So the question is, will the packages in the channel change over time? Yes and no. For a given hash, it will always be the same. Ideally, it will always be the same. So in theory, you could distribute this over IPFS or something and be confident that if you know the hash, you're definitely getting the same artifact. And you can verify that yourself once you have it downloaded. The channel itself, depending on which channel you use and how you use it, it will change over time because there will be security releases and patches and things.
Is there a way to lock down in time and say, I want... So I'm thinking about reproducibility. Two machines, and I install the same set of packages without giving a hash from the same channel at 2 different times, will they end up possibly having different package versions?
Yeah, so if you use the same channel and you run Nix build or something on 2 different machines at slightly different times, they can have different, depending on whether or like how you specified, they can have different results. I don't know if there's a way to lock down a channel to a specific like base child. Yeah.
So this is sort of my same question. The thing I always like, the first thing I went looking for in Nix is, okay, how do I specify a hash that defines the state of the Nix package reload that I want to build under? I want reproducible builds.
Right.
Anything.
Right.
I did eventually find that someone who's defining a way to do this, but it's kind of awkward, or was the last time I checked. So,
I'm sorry, the second,
Oh, sure.
The local package index that you showed, is that global? In other words, can I have per user configurations?
Right, so the Nix store that I showed you under /nix/store, it is global, everyone shares that same store, but each user has his own environment. So per user configurations use that store. So if, for example, you ask for node 0.7, I ask for 0.6, they'll both be in the store, in the same store, under different subpaths, and one will be symlinked to you and the other will be symlinked for me.
So different users can run Nix at the same time?
Different users can run different versions of things at the same time, but even the same user can if you just have different Nix shells open, for example.
So do you need a daemon or something like that?
Say again?
Do you need a centralized, like a daemon or something like that?
No, there's no daemon that I know of. It's just, well, we'll see it actually in a few slides as we go. But the basic idea is the way your system is configured is through symlinks and environment variables. One more? So you can garbage collect with Nix collect garbage. I'm not going to do that because there's a lot of stuff cached on here that will make the rest of this faster. But there's a nice way if you have a NixOS system, for example, or really any system with cron, that you can schedule this and have it periodically clean out your Nix store. The nice thing about having all that stuff in your Nix store is as you build newer versions of things like a project or a NixOS box or something, all those configurations are kept in your store. And so you can roll back as long as they're there. And so one thing that we'll do later is deploy a system, deploy it again, roll back to the previous, and then roll back forward to the most recent. And all that's possible because it's not yet been garbage collected. Okay, so let's move forward. So we covered Nix shell, but let's actually install fdubs to our environment. So we do this with Nix, and now we're going to use -i for install package. Sorry, I didn't document that here. And what that will do is put a symlink to, well, I'll just show you. Okay, so there's this .nix profile /bin. That's on my path. If you look at this file, it's actually a symlink back to the store. Wait, did I just lie? I did just lie. That's really interesting. This, well, I'm confused. I confused myself. Why is mine not a symlink?
No, go up to that mixed profile. And then do it again.
Oh, okay, of course. Yep. So we've got fdupes in there. If I were to install something else, shoot. What's the name of a package? How about Tmux is a good one. There we go. So now if I look at my local bin, okay, so yeah, so we can see the symlinks within that folder.
Sorry, one more question. So you're doing this without being in shell, right? Like this is outside of a Nix shell.
Yeah, this is just a regular bash session.
So this means if I log out and log back in, I will still have these, or?
Right. So with the nixenv-i, that modifies one of your dot files. It's like a .nix file, and that gets evaluated when you log in. So it's not in bash RC. I actually don't know where that lives, but yeah, it will be preserved when you log out and log in again. It's a little bit different if you have NixOS than if you just have Nix on Mac or Ubuntu.
Does the new Nix shell inherit that?
Yes. Yep.
I'm intrigued by the Nix builds like high level capabilities. Comment on the reasons for timestamps getting gamma recursion.
Do you mean in the name of the fdupes package?
Yeah. No,
That. Yeah, I'm not sure, but that sounds about right. There's a lot of information when you build a package that has to be stripped out. For example, if you're in a Git repo, you drop all of the .git content to compute the hash of that project. Timestamps might be the same kind of thing. I think if...
So that's probably the package name, like what the package retrieve. I don't know if actually has the update on that slide. Yeah, because Tmux has a different...
You're talking about this, right?
Yeah.
Next slide.
But look at Tmux. Well, that's just a simple...
So this was return.
Yeah.
Some, depending on the language and environment you use, you get factory,
That's what I'm aiming for.
and but it's not always true. Like even Haskell is really good to change
That's what I want to correct.
I think
Can you run Nix on an offline file system?
Yeah. So if you have a channel that's local, for example, or if you already have the stuff cached, it won't need to go out to the web.
No, that's not what I meant. I meant, like, you run it against something analysis wise.
What do you want to do with the ISO file?
state of an operating system or environment and apply operations.
Like a base image kind of thing?
Yeah.
Or you could use,
So I know NixOps works that way, because to deploy to EC2 we start with an AMI, or to deploy to VirtualBox we have to start with a whatever VMDK or whatever it is. I don't know if there's a way to do that in just regular Nix or NixOS. But aside from other tricks like this that try to get closer to build reproducibility, in theory your unchanging configuration should come close. It should approximate being able to reproduce the same output. And so you could use that as your base.
Absolutely. And that's why I would want to operate on something. I don't want to modify the system when the system from within itself.
Mm-hmm.
So you've got everyone's file system results, it's a metadata that it's going to literally disk and mesh.
Right. Right. That sounds more. I don't think that's really in the purview of Nix. That sounds more like a Packer or something.
Nix comes really close.
Well, let's move ahead so we don't get too deep in the weeds.
I just have a quick question.
Yeah.
Do all of these packages need to be written specifically for Nix? Or
Yes. So all of these packages are built using Nix expressions, which we're going to start writing pretty soon, and those are maintained on a Git repo called Nix packages.
just a community that takes
Yeah.
a bunch of packages and
Yeah.
works together?
Yeah. So if for example you use Nix as your package manager and you want to install some crazy tool that no one else has ever used in Nix before, you're going to have to write the build expression for it. Okay, so let's actually start building code with Nix. So I'm going to do a lot of copying and pasting and then just sort of quickly stepping through what the code does and take any questions as we go. I put a couple of editors on this shell. There's Emacs and Vim. If you want to install anything else, feel free to use nixm-i to do it. I find the easiest way to paste is just with cat, so that's what I'm going to use up here. So first we're going to make a file hello-world.c, and it's going to have this content. And I'm just going to cat out to hello-world.c, paste it, and then Control-D to finish. So now if I cat that file, there it is. And now I want to compile it. So we don't have GCC on here. So we're going to use Nix to do the work for us. So this will be our first Nix build expression or derivation. Let me paste this and then I'll explain what it means. So I'm going to paste this out to hello world.nix. So let's step through what this says. We have a function that takes a set as an argument, and that set needs one value called packages, and there's a default for it. So if this function is run and no packages is provided, we will import the default Nix packages from our Nix channel. Then we return a let expression. So we say let source equals, and then here we have a path again. This is like what we saw earlier with /var/log, except it's not a string, it's a path. And it's relative to where we're running this from. Or it might be relative to the .nix file. I actually don't know. So now we have a path binding, and then we're going to use this built-in function run command. This is building what's called a derivation. Basically everything in Nix comes down to building packages. That's its point, the language. And packages are called derivations because they all derive from this sort of base thing in Nix. You'll most frequently see the function make derivation, mk derivation. We don't need that. It's a little too complicated for this workshop, so we're just using run command, which is if you dig into the source, run command is just a wrapper around make derivation that sets some things for us. So this says call the library function run command. It takes a string as its first argument, and it takes a set as its second argument. So the string is the name of the thing that we're building. We just call it hello world. The set includes, in this case, the dependencies that we need to build this thing. So we need GCC to be able to compile a C program. and then we give it a multi-line string, which is just a series of commands to run. Yeah.
Can I specify a version of GCC?
You can, depending on what's available in your channel. So right now I'm saying give me whatever the default is. If I do nix and qap and grep for GCC, you'll see a bunch of different versions.
I assume that maybe the preference is to have a specific version then to make sure.
Probably, yeah. Yeah, if you cared about using the right version of C, yeah.
Wow.
Yeah. In other words, if you're not in just a workshop, yeah, it would probably be advisable to use the specific version that you want. And then if it's not available, this would fail, which you'd probably want.
Does it filter like what you can actually use in the build to where like if you tried to use Python or something, you'd be like, it's not going to let you. It will only let you use the tools you depend on there, or might it be able to get stuff from the system?
No, so in this environment, these commands are run in a sandboxed environment that doesn't have anything except for what you tell it should have. And in fact, it doesn't even have like writable directories. So it's run as a user whose home directory is called homeless shelter, and it's not writable. And so you can't even. So it's really all there to try to force immutability and reproducibility. You can do things like make temporary directories under /temp or using mktemp.
But it's just using a cache for all that stuff, so it's so you don't have to use.
Right. Right. So we do have access to the $out directory. That's just a variable. We don't know where that is, but it will ultimately be somewhere in our Nix store with some long SHA and before the name. So this says make this directory. So wherever the output of this package ends up being in our Nix store, we want to make a bin directory. And then we're going to compile, and the source file that we're compiling is a variable substitution. And then the output is going to be this binary. So we can build this using Nix build. And it will do everything that we just saw. And if you look at the contents of your directory, you'll see a result. That's the output of Nix build, and all it is a symlink into wherever that package ended up getting built in the store. So remember we made /bin/hello world, so we should be able to run the world, and there we go.
I haven't seen that directory. Look at the source, figure out when I build it, I put it in the same directory at the end. Nix store RLW.
Yours is almost certainly different than mine. Unless, so I don't know. It may be that Nix is actually doing a SHA of the build command, in which case, is it the same? Wow, awesome. I didn't know that. So yeah, apparently your output is the same as mine, which is pretty neat. But I'm guessing, and this is just a guess, if I change something about that build expression and put like a echo in there and then built it again, yeah.
It's not the same directory. We're all on the same machine. So are we all using the same binary?
We all, yeah, so we just, that was actually just a discovery to me as well. Because we all had not only the same build configuration, but the same exact build commands, it was smart enough to know that that's the same.
So cache, so
yeah.
ran it first, build it for everybody.
Exactly. Yeah.
So I have a question there. So there are times when I guess, especially for C++ program, you could get different output binary, even if you run the same command.
Really?
Yeah, well, that's what this chapter's talking about.
Yeah, that's awesome.
What is the alt variable?
What is the what?
Alt.
Oh, yeah. Out is a placeholder that we have access to that will be, eventually will be this Nix store directory.
Use the hash from the build description.
Yeah, it doesn't get computed until after this is built. So this is all built in a temporary directory somewhere. And then the hash is computed, that directory is made, and it's all moved into the Nix store under that directory.
Right.
Oh, you're right.
Yeah, it's only English, so
Right, because otherwise reproducible builds.
But how would, during the commands, how would be a temporary directory in some environment, and then it would be moved into the store.
Okay.
Yeah.
When it's done.
It's
a
a
zombie.
scene.
It's basically a
It's a
zombie.
copy. Right.
So we pretty much all did the build command, so if we did the build directory, would that hello world show up in like that NixOS query? Like package?
No, because that's only searching the Nix channel. Yeah, you could tell it about other channels, but it doesn't search like a Nix store, for example. You can see what packages you have locally installed with just a -q. So if you do nix and -q, you can see I've installed these two into my environment. But since I didn't install Hello World, I just built it. It's not in my environment, so I can't just run Hello World. What's that?
There's also Nix store you do, that I can command line.
Oh, Nix store. Yeah, actually, I've never used that. Oh, awesome. So the answer is yeah, you can use Nix store. Cool. Let's move forward.
Just one more question there. The run command takes a string parameter, which in that case was hello world. What is that string for?
That's used to name the package. So you can see in the Nix store. Wait, let me make sure that I'm not lying. Yeah, so it's used for the Nix store to name the output directory.